Hello, I'm Matt Galloway, and you're listening to The Current. Andrew Davies has traveled a lot, but he has never experienced anything like the turbulence on yesterday's Singapore Airlines flight from London to Singapore.
There was so much screaming, and I realised the gravity of it when I looked over my shoulder and saw the people sitting behind me with a lady who had a big gash in her head and blood pouring down her face.
The plane hit what Singapore Airlines describes as severe turbulence and suddenly dropped 1,800 meters.
Obviously, lots of people needed some help, but we tended to this gentleman and I helped carry him, get him out of the seat, and we lay him on the floor so that some medical professionals could administer CPR. They gave him CPR for at least 20 minutes.
That 73-year-old British man died, likely from a heart attack, and dozens of passengers on the plane were injured. The plane eventually made an emergency landing in Bangkok. Video from inside shows chaos, oxygen masks hanging, overhead bins dented, blood on the seats, items scattered everywhere. It is extremely rare for turbulence to kill someone, but turbulence itself has become more common. Paul Williams is an atmospheric scientist at Reading University in England. Paul, hello.
Good morning, Matt.
We heard that passenger there describing his experience. Knowing what you know, what do you think that kind of extreme turbulence would feel like if you were on that plane?
Oh, I shudder to even try to imagine it. It must have been horrendous. I think it probably was something like being on a roller coaster without any restraints in place for those passengers who didn't have their seatbelts on. There is a kind of turbulence that we classify as severe, and that has a precise definition. It means that the downward motion of the plane will exceed 1g. In other words, if you're not seatbelted, gravity cannot pin you down into your seat strongly enough, and you'll lift up, you'll become a projectile inside the cabin. And by all accounts, that's what happened on this very unfortunate flight yesterday.
The plane dropped 1,800 meters, 6,000 feet in the space of just minutes.
That's what I've seen in reports. Now, it's important to understand that that was not the turbulence directly. The turbulence will certainly have shaken the plane up and down, and it might have felt like tens or hundreds of feet. I think what actually would have happened, that drop, I think, by 6,000 feet over a few minutes, was almost certainly just the pilots maneuvering, lowering their altitude, descending to try and get out of the turbulence. So it was a combination, I think, of some terrifying turbulence, shaking the plane up and down, and then a controlled maneuver by the pilots just to try and escape it and get as far away from it as they possibly could.
Anybody who's flown has probably experienced some degree of turbulence, being bounced around a little bit on the plane, and a warning to fasten your seatbelt. The turbulence might be ahead. What causes that? What causes turbulence?
Well, it's an interesting question. Turbulence is all around us in fluids. It's in your cup of coffee, it's in your bathtub, and it's in the atmosphere. And in the atmosphere, there are different generation sources. One of those would, of course, be flying through a storm. Nobody wants to do that. In a storm, we have rising warm air called updrafts, and we also have downdrafts. So there's vertical motion, and just those air currents pushing on the wings of the plane is enough to cause turbulence. But even away from storms, flying over a mountain range, for example, as the air flows over mountains, of course, it has to go up and over the mountain. And that can generate a kind of wave called a mountain wave, which can become turbulent. And there's a third kind of turbulence too, called clear air turbulence. And that's got to do with these fast air currents called jet streams. If the wind shear in the jet stream is too strong, that can cause this invisible clear air turbulence, and it tends to be hazardous because the pilots can't see it on the radar, and the seatbelt sign tends to be off, and you're in clear blue skies, and there's often no indication that this severe turbulence is just ahead.
Are we seeing an increase in turbulence?
I think so. This started out as a theory we had about 10 years ago. We were running atmospheric simulations, computer simulations of the future, and they were indicating that the amount of severe clear air turbulence was going to double or treble in the next few decades because of climate change. And more recently, last year, we published a study that confirmed that, in fact, those increases have already begun. We looked back at historic data going back to 1979, which is when satellites first began observing the jet stream. And when we crunched those numbers, we found that from 1979 to the present day, there's already been a 55% increase in the amount of severe turbulence. So I think those increases from climate change have already begun and are only set to continue into the future if the climate continues to change as we expect it to.
How does climate change lead to more turbulence?
Yes, that's the big question. What is happening is that, well, what drives the jet streams in the first place is this north-south temperature difference. Okay, so north of the jet stream, it's cold. South of the jet stream, it's warm. And it turns out that climate change is warming the warm air to the south of the jet stream more than the colder air to the north of it. So the temperature drop across the jet stream horizontally is being made stronger by climate change. And that's strengthening the wind shear in the jet streams. And again, we have clear evidence of that, not just from computer models of the future, but looking historically as well since 1979. Today, the jet streams are 15% more sheared. So they have 15% stronger wind shear than they had just 40 years ago. So all the pieces of the jigsaw are there. The link from carbon dioxide to temperature changes to a stronger, more sheared jet stream and more turbulence. It's wind shear that is the generation mechanism for this invisible clear air turbulence.
Do you expect an increase in what Singapore Airlines described as extreme turbulence?
Well, funnily enough, we have usually not included extreme turbulence in our studies because it's so rare. We almost thought, what's the point? So we have, we categorize it into light, moderate, and severe. And the next one up is extreme, but it's so rare that it's usually omitted from academic studies. So I don't have any hard numbers on the future for extreme turbulence. It's so rare. I mean, I was looking at turbulence fatalities, which are really rare. The last one before this week's was in 2009. And the one before that, I think, in 1997. So it's not happening every year. It's more like once a decade, if that, fortunately. But I do think the suggestion is that not just light, moderate, and severe, but also this really extreme turbulence is probably on the increase as well.
Are there specific routes? You mentioned mountains, but aside from that, are there specific flight routes that have seen a large increase in turbulence?
Yes, we've looked at the hotspots, and the North Atlantic it really lights up on our maps. So any flight from pretty much anywhere in Canada to pretty much anywhere in Europe will be flying through atmosphere that today has 55% more turbulence than in 1979, and in the future continues to be a hotspot with a doubling or a trebling in the amount of severe turbulence. So mountains, jet stream regions are the other hotspots. You really can't get away from turbulence. If you're in the tropical parts of the country, that's where the storms are very powerful and you get this storm-related turbulence. But as you move towards the poles and get into the middle latitudes, that storm-related turbulence drops off, but the clear air turbulence kicks in. So there's really no escape. I can't think of anywhere on the globe that is free from turbulence.
You'll often hear the pilot before the flight say, we may have a period of turbulence here or there, what have you, kind of predicting what the flight is going to be like. How accurately can turbulence be predicted?
More accurately than you might think, given that turbulence is probably the hardest problem in physics. It's a deceptively, really horrendously difficult subject. But we do have forecasts of it. And in fact, I've spent the past 20 years of my career working on these turbulence forecasting algorithms. They're just like a weather forecast, but instead of mapping out temperatures and rainfall, they're mapping out where the turbulence will be. And we know that they're about 75% accurate. So of all the turbulence that's out there, they can accurately forecast up to 18 hours ahead about 75% of that turbulence, which of course is good. It means pilots know this before departure and can plan smoother flight routes accordingly. But it also means there's another 25% out there that even the best forecasting systems today cannot forecast. And I'm working very hard with my colleagues to try and improve those forecasts.
I guess just in the last couple of minutes that we have, what would you say, because there are people who have a fear of flying, people might be nervous flyers, people might want to know, that the flight is going to be as smooth as possible. And now they're hearing that turbulence has gone up dramatically. What would you say to somebody who hears this story? It sounds like a bit of a nightmare to them, and they're worried about what may happen when they get on the plane.
Indeed, and I'm always aware that you almost certainly have listeners right now who are on their way to the airport. I think it's important to remember that flying is the safest form of transport. Safest form of transport ever. You're more likely to be injured in the car on your way to the airport than you are on the flight. Severe turbulence is rare, and it even will remain rare if it doubles or trebles. Something like 0.1% of the atmosphere at flight cruising levels has severe turbulence in it. So you take 0.1% and double it or treble it, it's still only 0.2 or 0.3%. So the chance of your flight hitting that little tiny part of the atmosphere is really tiny. Just keep your seatbelt fastened and try and have a nice flight would be my advice.
You sound like the pilot. Keep your seatbelt fastened.
Yeah, absolutely.
Paul, thank you very much for this.
It's been a pleasure. Thanks, Matt.
Paul Williams, atmospheric scientist at Reading University in England.